Alright, welcome back to this video. Welcome to Master's Space Video Tutorials, and in this video we are going to look at power reducing formula. Power reducing formula. In fact, trust me, you're going to learn it. We will be looking at T formula also and all that, and trust it's going to be brutal. Alright. Now, power reducing formula, and it's that we have the T formula. The T formula. In fact, it's the idea of the power reducing formula that we use to get the T formula. Alright. So the first formula for the power reducing is, don't forget, in case you can't remember, when we were deriving the formulas for half angle, we reached a point where we had sine square A to be equal to 1 minus cos 2A over 2. Then we continue to take the square root on both sides. Then after that, we said that since we are looking for the half angle for sine, then we divide the argument by 2. And that gave us the half angle. So this one that we have here is the first formula for the power reducing formula. Alright. The second one will go for the cosine. And that is 1 plus cos 2A over 2. Now, if you can see it critically, you can see that it just by multiplying 2 by the argument here, or twice of the argument here, is going to give you the one there. Very good. Then for the tan, we are going to base on tan square A, which is equal to 1 minus cos A over 1 plus cos 2A. Alright. Very good. So these are the three formulas for power reducing. So let's quickly go and derive the ones in the T formula. So we move on to the T formula. The T formula. Alright, now from double angle, we are starting it from this side. From double angle, we know that the double angle for tan, that is tan 2 theta, is equal to 2 tan theta over 1 minus tan square theta. And I took you through how to prove this formula and all that. Very good. Now with this, we are going to replace A with A over 2. Alright? We are going to replace A with A over 2. Or let me say, we are going to replace theta by theta over 2. Okay. So let's replace theta to be equal to theta over 2. Hope you can see that. Very good. So whenever you see theta, put theta over 2 there, and that's going to give us tan 2 times theta over 2, which is equal to 2 times theta over 2, all these over 1 minus Alright, so that is that for that. Now, here, then we are going to let, hope you are following. Then we are going to let, all that we did here is that we quoted from double angle for tan, and that is equal to this. Then after that, you replace, if your argument is 2A, you replace A by A over 2. But here we are using theta, so that's why we are using theta over 2. So whenever you see theta, replace that by theta over 2. Very good. Let's continue. So that is that. Alright. So now, after the substitution, we are having here to be done theta over 2. We know that here, let's move on one step again. I don't want to skip any step. Here we are going to get tan theta to be equal to 2 tan. Very good. So from here again, let t to be equal to tan theta over 2. So when we let t to be equal to tan theta over 2, what it means is that wherever you see theta over 2, put t there. So we end up by getting tan theta to be equal to 2t over 1 minus t squared. 1 minus t squared. Alright, so that is going to be tan theta. That is going to be for tan theta. Alright. Then we use this to find sin theta and cos theta. Because we know that tan theta is equal to y over x. Alright. Then we can use the Pythagorean identity to get the radius also. So here y is equal to 2t, then the x will be equal to 1 minus t squared. Alright. Then the r will be unknown. So let's go and look for the r. Because for you to get sin theta is y over r, and for you to get cos theta is s over r. Very good. So x squared plus y squared, that's Pythagorean theorem. So this is 1 minus t squared plus alright, so let's go for that. Very good. So for us to find r, we take the square root of 1 minus t squared all squared plus 2t squared all squared. Alright. So when you simplify this, what is that going to give you? And when you simplify that, you are going to get, let's do it. So with this, okay, so we are going to get negative 2t squared okay, so negative 2t squared, then, alright, minus, so we have negative 2t squared. So you let's right click that part and simplify it. 1 minus t squared. Okay, all squared. So this is 1 minus. Alright, so this you get 1 minus t squared plus t squared. Oh, so this will cancel this. So to be left 1 minus, to be left with 1 minus t squared. Yeah. To be left with 1 minus t squared. Let's look at it again. This time this, you get this. This time this, you get this. Then this time this, you get this. This time this. Oh, sorry. That's going to be power 4. Because they're going to get 4, then it gives you power 4. Alright, so now we have negative 2t squared plus t to the power 4. Alright, so that's what we have. Very good. So the r is equal to the square root of 1 minus 2t squared plus t to the power 4. In mathematics, we don't take things serious. You end up in error, alright? So it's good for you to take your time. So here you get 4t to the power 4. Very good, because 20 squared is we get power 4. Very good. So that's what we have for that. And we can now, so we are still deriving the formulas. We have the first one, the second one, and we are going for the third one. And that is what we are in now. So here, when you solve that, you get R to be equal to, okay. So you are going to get R to be equal to, okay, so for us to go for sine and cos theta, we look for the R. That's the radius part, right? And that is going to give us t squared plus 1. This is just algebra. Very good. So now that we have the R, then we can go for sine theta. So what is sine theta? That is y over r. So y over r is going to be 2t over t squared plus 1. So the r here is t squared plus 1. Very good. Then we go for cos theta, and that is s over r. And that is going to give us s is 1 minus t squared over t squared plus 1. Very good. So that is that for that. Don't forget these formulas. Never forget these formulas. This is the first one. This is the second one. This is the third one. And that is the fourth one. And that is the T formulas. Alright? And also, it must be upheld. The moment we ask you what is sine theta, then, or the moment you see it in a question, know that sine theta is equal to 2t over 1 minus t squared, and also cos theta is 1 minus t squared over t squared plus 1. Alright, so always don't forget that. So that is what we have on the board. Then we have an alternative way to get these formulas, okay? But I think this one is enough. So let's move on to solve our first example. So in the first example, we will be looking at alright, so we have our formulas here and our first question on the board. Alright, so using the key formula, solve sine theta plus 2 cos theta is equal to 1 for angles between 0 degrees and 360 degrees. Wow. How do we do this? It's just like how we do this. Let's move on. So now we have sine theta plus 2 cos theta to be equal to 1. Very good. So just go for 8. We are using half angle. Sorry, T formula. So just go for 8. You know sine theta to be 2t. That's why it must be open. 2t1 plus t squared. 2t 1 plus t squared, or t squared plus 1. They are the same. Plus 2 multiplying cos. And we know that cos is 1 minus t squared over 1 plus t squared. is equal to 1. Very good. So you can see what is on the board. We are going to this is just algebra. So when you perform the algebra, then you end up by getting a quadratic what? Equation. Alright. So looking at this equation, let's move one step. Here 2t over 1 plus t squared plus 2 multiplying 1 minus t squared 1 plus t squared equals 1. So you can see here you ask yourself of the LCM. And the LCM that we can get here is 1 plus t squared. So with the LCM of 1 plus t squared, we are going to use it to multiply throughout. Alright? So we multiply this by very good. So this cancel this cancel that. Then we are going to have 2t plus 2 1 minus t squared to be equal to 1 plus t squared. Very good. So having this, then we can send this to this side. Alright, let's send everything to this side. So 2t plus 2 minus 2t squared, which is equal to minus 1 minus t squared equal to 0. So this is going to give you negative 3t squared, this, negative 3t squared. Then this plus 2t, the constant 2 and negative 1, so this is plus 1, which is equal to 0. So we end up by getting, even with this, we can multiply through by t, negative, so that the negative will go. So when you multiply through by negative, you get 3t squared minus 2t minus 1 equals to 0. Alright. So with this, then you go by 8. You know the method in solving a quadratic equation, whether by formula or by completing the squares or by factorization. Alright. So when you do that, you're going to get t to be equal to half, or you get t to be equal to negative 1/10, or t is equal to 1. Very good, very good, very good. Okay, so when you get t to be equal to 1, don't forget, it's not t that we are looking for, but we are looking for theta between 0 degrees and 360 degrees. Alright, so then you quote, but t is equal to tan theta over 2. Since we know that t is equal to tan theta over 2. And now this is if theta is between 0 degrees and 360 degrees, then theta over 2 will be between 0 degrees and 180 degrees. Don't forget, please, don't forget that here we are dealing with what? Half angle. But here we are saying that let's look at the interval. The interval between us is but the substitution that we are going to do here is going to be a half angle. Alright. Now, for this theta, we are working within 0 degrees and 360 degrees, no problem. But because of the half angle, then we have to go for the half angle. So let's look at that. And that is dividing both sides by 2. When you divide all by 2, you are going to get 0 degrees less than or equal to theta over 2 less than or equal to 180. So it means that with this, for half angle, we are working within an interval of 0 degrees to 180 degrees. But for just theta, it will be 0 degrees to 360 degrees. I hope it's clear. All right. So let's go for that. The question stated it in theta because the equation we have here is in terms of theta. But now we are going to do a substitution of half angle. And we need to know the interval that will be for the half angle. So now that is known, then we can go on to do our substitution to find theta. Alright, so we know that tan theta over 2 is equal to t. And we have t1 and t2. t1 and t2. So for t to be equal to negative 1 over 3, let's see what is going to happen here. So for theta to be equal to negative 1 over 3, we are going to take the tan inverse of both sides. When you take the tan inverse of both sides, you get tan inverse of negative 1 over 3. So we get theta over 2 to be equal to 6161.57 degrees. So that is what we are going to get for theta over 2 for the first one. So let's go for if t is equal to 1. Now, if t is equal to 1, we get tan theta over 2 to be equal to 1. So theta over 2 to be equal to tan inverse of 1. And theta over 2, we know that tan inverse of 1 is going to give us 45. So it is going to be 45 degrees. Alright. So, now it's clear. You can now see that for half angle, so we are going to state for the 2. We are going to state for the 2. We are going to use the interval of both for the half angle and for the angle itself. Very good. So now you can see that 45 degrees and 161.57 degrees are all in this interval. You can see that they are all in this interval. Very good. Now, for you to get theta, let's try for theta and see if that one is going to be in the interval of 0 degrees and 360. So for you to get theta, just multiply this by 2. Okay? And when you multiply that by 2, you are going to get 323.14 degrees. Alright, and that's what you're going to get for theta. Now, let's look for the theta here. You multiply 2 by 45 degrees, and this one too, you are going to get theta to be 90 degrees. Wow! So you can see that for theta, we are within the interval of 0 degrees and 360 degrees. And for half angle also, we will be in the interval of 45 degrees and we will be in the interval of 0 degrees and 180 degrees. Thank you and see you in the next video. Alright, sorry. In this video, we are going to add one more question. So let's come back for question 2. Find the value of t which satisfies equation b plus 2 sin theta plus 2b minus 1 cos theta equal to 2b plus 1. Very good. Now the question is saying that where b is a a non-zero constant. A non-zero constant. If b is equal to square root of 3, find two acute angles which satisfies the equation. Which satisfies the equation. Alright. So a question says we have to first find the value of t which satisfies the equation. Then after that we find two acute angles which satisfy the equation. So we have two questions embedded inside here. After the t, and you know already, before you can get the theta, you need to go for t first. Alright. So let's move on. Now we have b2 to be equal to square root of 3. So let's move on to the first thing. So the first thing to do, we know that we have b plus 2 sine theta plus 2b minus 1 cos theta. 2b plus 1. Alright. Then we replace our formula for sine theta and cos theta. The formula must be of F. Alright, so then from here what will you do? That is the LCM, this algebra. So let's multiply through by 1 plus t squared. Let's go straight to the point. When you multiply through by 1 plus t squared, you cancel the denominator. It will cancel the denominator. Two b plus 1 multiply t squared plus 1. Alright, so having this, then we move on to expand to simplify. Two bt plus 4t, so 2bt plus 4t, then plus 2b minus 2bt squared. 2bt squared. That is, we multiply this by this, then this by this. So after that, we get minus 1 plus t squared to be equal to the other side. When you expand this one, you're going to get 2b plus 2bt squared plus 1 plus t squared. Very lengthy. Alright, I believe you can see from there. Yeah, I've checked it. You can see from there. So that's t squared. I just checked that. Very good. So now let's move on. So this will simplify. This will simplify to 4bt squared. 4bt squared. This is just algebra. Do it. Minus 2bt minus 4t plus 2 is equal to 0. So you can see that we now have it in the form of a quadratic equation. So with this, we can divide each term by 2. So we get 2bt squared minus bt minus 2t plus 1 equal to 0. Alright, so having this, if you want to solve it, you see, this we can leave it in the form of a quadratic, alright? When you leave it in the form of a quadratic, then you go and use the almighty formula to do that. So I'm leaving that for you to do. So here you get Bt minus Bt is equal to 1. Then, or 2t minus 1 should be equal to 0. Alright. So here we get t to be equal to 1 over b. Then t here will be equal to half. Then we go and quote because we know that so but t is equal to tan of the half angle. So tan of the half angle is equal to, let's first equate. We can first coming very good. We can first equate it to half, and this is going to give us theta over 2 is equal to tan inverse of half, and theta over 2 is equal to, now tan inverse of half. Okay, let's do it straightforward. Let's go for the theta. So it will be 2 times tan inverse of half, and that is going to give you 53. Make sure that you be in degree mode to do that. 53.13 degrees. And that is the first solution. Then we go for when t is equal to 1 over b. But we know that b is equal to square root of 3. So t is equal to 1 over b is the same as 1 over square root of 3. That when you rationalize, in case you go to rationalize, I'm going to get 3 square root of 3 over 3. I'm going to get square root of 3 over 3. Very good. Okay. So tan of the half angle is equal to, you can use this or that. Then theta will be equal to, theta over 2 will be equal to tan inverse of 1 over square root of 3. And theta will be equal to 2 times tan inverse of 1 over square root of 3. And finally, this is going to give you, this will give you 30 degrees. Then 30 degrees times 2, you get 60 degrees. Alright, so we end up by getting theta to be equal to 53.13 degrees or 60 degrees. And you can see both of the angles are within the interval of an acute angle. When you say that, find two acute angles which satisfy the equation. And surely you can see that this and that is an acute angle. Therefore, it can satisfy the equation. Alright, so that is all. Thank you and see you in the next video. In the next video, we are going to look at the minima and the maxima of trigonometry.